Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad NAZWAN HAKIM bin Muhammad SHAHRUL and my number metric is 33DCE21F1073.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris bin Muhammad Nurli and my matrix number is 33DCE21F1055.
And today we're going to present a tensile test on mild steel. So the objective of this test is to study the mechanical properties of mild steel specimen under tension load. So the apparatus used are a universal testing machine, dial indicators, extensometer, scale, and vernier calipers. So step 1 of to do tensile test on mild steel is first, we must measure the initial diameter of the tension test sample in two perpendicular directions using vernier caliper. And then we got the DIX is 12.16 mm. And then we got the DIY is 12.60 mm. So the average initial diameter is 12.6 mm. So step 2, measure the length of the specimen between the grips using a scale. So the length of the specimen between the grips is 100 ATC millimeter. So step 3, punch the mark are made at a distance of 2.5 diameter. So the distance is 2.5 times 12.6 equals to 31.50 millimeter. Okay, and then step 4, insert the specimen into its position and mount the extensometer on the specimen. And then step 5, reading on the dials A and B of extensometer are adjusted to 0. And we got least count of extensometer is 0.01 millimeter. And then step 6, experiment is conducted. Load extensometer reading are read at regular intervals of load up to the yield point. Inventory scale readings are not till the specimen failure. And this is the result. So the next step, I will pass to the Faris.
Okay, so for step 7, we got graph for load versus ivory scale reading. And this is the graph. And for step 8, we got graph for load versus extensometer reading, and this is a graph. Okay, so we got x axis is equal 4.3 and y axis is equal 9.5, and lastly we got slope equal 2.21. And then for step 9, we join two pieces of the test sample and measure the diameter at the neck on the specimen. And we got final diameter is equal 8.83 millimeter. And for step 10, we measure the final length between 3 punch marks. And we got final length between the punch mark is equal 87 millimeter. Okay. For step 11, is observations and calculations from the experiment. So for the yield stress, we use a formula: load at yield point divide by original area, and we got 336.89 Newton millimeter per square. And for the tensile strain, we use a formula: ultimate tensile strain load divided by original area, and we got 481.23 Newton millimeter per second, per square. And for modulus of elasticity, we use a formula: slope times 1 over least count times coach length divide over original area, and we got 212.70 GPA. And for percentage elongation, we use final length minus punch marks times 2 over punch marks times 2 times 100, and we got 38.36 percentage. And for the percentage reduction in area, we use original area minus final area of at neck divided by original area times 100, and we got 50.91 percentage. So that's all from us. Thank you.